Hi everyone, let's move on to a new topic which is nothing but the laws of indices. Let's focus on the first law, which is if you have a raised to the power m multiplied by a raised to the power n, that is if the bases are same but it's a product. So what you're doing over here is a product of two numbers having the same base. This is same as writing a to the power m plus n. Let's take an example. For example, if you have, let's consider 3 square multiplied by 3 to the power 3. This is same as writing 3 to the power 2 plus 3, which is 3 to the power 5. Alright, if you individually find out the value of 3 to the power square, that is 3 power square, which is 9, and 3 cube, which is 27, and multiply 9 into 27, the result is going to be the same as 3 power 5. Moving on to the second law, which is a quotient law, or let's write it as if you have a to the power m divided by a to the power n, or you can also write it as a power m divided by a power n, that is you have the same base a but different powers, or it may be same powers, that's fine, but the same base, definitely the same base, you can express it as a to the power m minus n. Let's take an example. So if we have, let's write it as 2 to the power 3 divided by 2 square, we can write it as 2 to the power 3 minus 2, which is 2 power 1 or 2. Let's go for the third rule, which is nothing but if you have a real number a to the power m and it is further raised to a power n, we can multiply the powers like this. Example, if we have 2 to the power square or 2 squared to the power 3, this is same as writing 2 into 3 is 6, 2 power 6. We can further prove it. For example, let's focus over here on the left hand side. So on the left hand side, let's put it as LHS. You have 2 squared raised to the power of 3. What is 2 square? That is 2 multiplied twice, 4 power 3. 4 multiplied 3 times, or 4 into 4 into 4, is nothing but 64. 4 into 4 is 16. Multiplied again by 4, you get 16 into 4, 64. On the other hand, if you look at the RHS, it's 2 to the power 6. 2 to the power 6 is nothing but multiplying 2 6 times. 6 times. So count with me. 2 into 2 is 4. 4 into 2 8. 8 into 2 16. 16 into 2 is 32. 32 into 2 is 64. That is a total of 2 multiplied 6 times. You get 64. The fourth law is the zero index law. So if you have any real number, let's consider it a, raised to the power 0, the value would become 1. For example, if you have 2 to the power 0, see, 2 to the power 0 means you're multiplying 2 0 times. So if you're multiplying 2 0 times, it's simply going to be equal to 1. If you even write down 10,000 raised to the power of 0, it is going to be equal to 1. In other words, any real number, any real number raised to the power 0 is going to be equal to 1. Moving on to the fifth law, which is nothing but the negative index law. So with the negative index law, let's consider a real number a raised to the power of minus n. So you're raising to a negative index power. When you raise it to a negative index power, it is same as writing a to the 1 by a to the power n. So this is nothing but a reciprocal, right? It is nothing but giving you a reciprocal of a to the power n. Okay, let's consider an example. So if we write down 2 to the power minus 3, it is same as writing 1 by 2 cube. We can also go ahead and prove this. See, in order to prove this, you need to identify a pattern. When we write down 2 power 4, we are actually multiplying 2 4 times. When we do 2 cube, we are actually multiplying it 3 times. That is, between 2 to the power 4 and 2 to the power 3, you have done a division by 2, right? Similarly, if you go for 2 square, you're doing 2 multiplying 2 by 2 times. Multiplying 2 times. So between 2 cube and 2 square, you're actually doing a division by 2. Similarly, if you go for 2 to the power 1, you're actually doing a 2, just multiplying it one time. To summarize, let's write down again. 2 power 4 is nothing but multiplying 2 4 times. 2 power 3 is multiplying 2 3 times. 2 power 2 is multiplying 2 2 times, and 2 power 1 is multiplying it 2 times, just one time. From here, if we go to 2 power 0, you're actually multiplying it 0 times, which is what's giving you 1. You can't multiply, if you multiply 2 0 times, you actually get 1, as we discussed some time back. But when you go for 2 power minus 1, see, observe a pattern. 2 power 4 multiplying 2 4 times. When you go back to 2 power 3, you're actually dividing this expression by 2. When you go from 2 cube to 2 square, you're dividing this expression by 2. 2 square to 2 power 1, again you're dividing it by 2. 2 to the power 1 to 2 to the power 0, you're actually dividing this by 2, which is why you're getting a 1 here. When you do 2 power minus 1, you're again going to divide it by 2, keeping up the consistency with the pattern. So 2 power minus 2 is nothing but 1 divided by 2 into 2. Hence, 2 to the power minus 3 is going to be 1 divided by 2 into 2 into 2, which is nothing but 1 by 2 cube. Moving on to the sixth law, which is nothing but product to power rule. So for product to power rule, you have AB to the power n. When you have AB to the power n, A and B, both of them real numbers, you're expressing a number in the form of product of two numbers, both of them raised to a power n. You can write it as A power n multiplied B power n. This is not the same as the first law which we did. Over there, the base was identical but the power was different. Over here, both the numbers or the bases are different but the power is same. Let's consider an example. Let's say you have 6 cube. You can write it as 2 multiplied 3 cube or 2 cube multiplied 3 cube as per the law. We can also go ahead to prove this. Let's go ahead with the LHS. The LHS was 6 cube. 6 cube is basically 6 into 6 into 6. So 6 times 6 is going to give you 36. Multiply it with one more 6. You will be getting 216 as your answer. And RHS was nothing but 2 cube followed by 3 cube. 2 cube is nothing but 8 and 3 cube is nothing but 27. So if you multiply 8 with 27, again you're going to get 216 as your answer. Another thing which we have is called as fractional indices. So to generalize a fractional index, let us consider a real number a raised to the power 1 by n. This is same as taking the nth root of a. This is nothing but, this is not n root a, this is the nth root of a, where n and a, both of them belong to the set of real numbers. For example, if you have cube root of 8, this is same as writing 8 to the power 1 by 3. Let us take more examples. When you have root over of 64, this is same as writing 64 to the power half. That is, when nothing is mentioned over here, we are talking about n equal to 2 or the square root. 64 power half or root over of 64 is going to give you 8. But when you write down 3 over here and 64, that is nothing but 64 to the power 1 by 3. That is the cube root of 64. Cube root of 64 is nothing but 4, because 4 cube gives you 64, and you can write it as 4 power 3 1 by 3, which is nothing but 4 power 3 into 1 by 3 or 4 power 1, which is 4.